There it goes. So what I'm going to do, I'm going to look at 7.2, and I'm going to start off with some terminology, then we're going to jump into some problems. In section 7.2, we're dealing with sort of well, geometry is what it is. And we start out with the idea really of a plane. And a plane is going to be just a flat surface. So this is going to be our plane. And a plane is basically a theater for geometry. It's where we're going to do geometry. So we're going to use this flat surface. There are other kinds of surfaces. You could have, for example, a sphere, and there's geometry that deals with that. And there's some interesting properties that will change. For example, you can come up with, appears to be, triangles that are on a sphere, but you can get degrees greater than 180 degrees in those kinds of triangles. But triangles on a flat plane, they're going to always have 180 degrees in them. So this is a particular kind of geometry we're going to be dealing with. Now, the parts of things. A point. A point is basically a dot. Now, technically speaking, it's infinitely small. It's this tiny location in space that's really, it's infinitely small. It doesn't have a width or a length or anything. But because of the limitations of just living in the physical world, we got to give it what looks like a length and a width, however small it is. But technically, it's this sort of tiny little location, say in the middle of this dot. Now, with points, we construct the other shapes. So we can have what's called a line. A line at minimum needs 2 points. Because if you have just one, we're not sure where this line is, we're not sure what it's exactly doing. But if you put a second point that the line passes through, we know exactly what this line is doing. We can place it in space. Oftentimes, lines are represented with this cursive L. Now, related to a line is a ray. An array it's part of a line. You have a starting point, and then you have a second point that tells you in which direction this ray is going to be going, and the ray passes through those 2 points. Now then you have a line segment. And a line segment's just a part of a line between 2 points. So those are sort of some of the basic shapes you're going to be dealing with. Well, we've got one more. Let me show you. We have something called an angle. This part's called the vertex. This is a side. This is another side. And we can label angles in different ways. For example, we'll sometimes talk about an angle using the vertex. So the vertex will be labeled. And so refer to this as angle A. Now we're going to talk about measurements of angles, and we measure angles using degrees. So the amount of degrees in angle A we use this, the measure of angle A. And then you could see it referred to like this. Sometimes angles are referred to as this. So that's angle Y. And then the degrees at angle Y same thing. The measure of the degrees in angle Y. All right. So let me do a problem here. So I'm going to need to draw a picture. Oh, if you don't mind switching off your microphone just for now. I think what it does is it blows up that window. So for this example, we're going to have a line. So what we've been told, and this is sort of the notation we use for this type of problem, the distance from A to B, here to here, is going to be 21. Now, the distance from B to C is going to be 14. And then finally, the distance from A to D, well, that's going to be 54. They're asking for the distance from C to D. Now, here's the thing. We don't know what that distance is. And to help out, what we're going to do is come up with a variable. Now, the idea of a variable is it's a number. So we're going to get more into algebra later, but they're going to throw some at you right now. Numbers like 4, 5, 2.5, square root of 2, well, we know what these are. But a variable is just like a number. It's just one we haven't really encountered yet. So it's sort of like if you were looking for a place to live, you're on Craigslist, and you're going to go, say, you're going to share a house with a group of people. And what's going to happen is you know certain facts, that these are people. You're moving in with people. But you don't know exactly, well, who? So in a sense, the people here are variables. They are human beings. We just don't know which ones. So we're going to treat them as human beings. We're not going to treat them any differently. But we don't know specifics yet. So there's certain things that we can't do. So we don't know what kind of presents they would like for their birthday, if they celebrate their birthday. We don't know if they have any favorite foods. We don't want to make assumptions about those things. But we do know they are people. So we need to treat them as people. Variables are the same way. They're numbers we don't know. So we need to treat them as numbers. We can add things to them. We can subtract things from them. We can multiply things to them. But we can't go too far. What's 3 plus x? Well, as long as x is a variable, it's a number. It makes perfect sense to add 3 to another number. But 3 plus x, that's as far as we can go. We don't know what number x is. So we have to leave the addition like that. We can treat x as a number, but then we have to identify x first before we can go through and finish the addition. So this is going to be the same thing. So this, it's a number, we just don't know which one. Now, identifying unknown numbers is something we're going to do later, and that's the field of algebra. So we're going to kind of get ahead of ourselves, but hopefully this won't be too much trouble. I'll introduce you to some of the tricks we use in this chapter when working with trying to discover unknown numbers. So what we have is this. The total distance from A to D is 54. This total distance includes 3 smaller distances. This and this and this. So if we add these 3 together, we're going to get 54. So what we can do, we can add these 2 for sure. So what we can do, we want to discover what x is. So we can try to answer this question. 35 plus some number gives us 54. What is that number? So you can kind of guess and check and see it till eventually you get it right. There's another technique you can use. To identify x, we can subtract 35 from both sides. And what we're going to get is x will be 19. So that means C to D is equal to 19. All right. So any questions about that? And if you have any questions, you can switch on your microphone. That's totally fine. All right. So let's go back to angles. So types of angles. Well, we have what are called right angles. Now, these are angles that are said to have a measure of 90 degrees. And what they look like is basically a chair with a perfectly horizontal seat and a perfectly vertical back. And to represent a 90-degree angle, we do it a special way. A little square on the inside. This represents 90 degrees. So instead of writing 90 degrees, we just use that symbol. So this brings up a certain kind of angle called an acute angle. Now, this is an angle with a measure between 0 and 90 degrees. So typically what an acute angle looks like something like that. That would be an acute angle. Now there's something else that goes with these right angles. It's the idea of complementary. Two angles are complementary if they sum to 90 degrees. So let me do an example. So angles x and y are complementary, but the measure of angle y is 62 degrees. Find the measure of angle x. So we want to identify the measure of angle x. Now, again, what we're going to have to do are use some of those algebra techniques we're going to look at in the future. But it's okay if we start working with some of those now. So because they're complementary, we know this. X plus y equals 90 degrees. Now we know the measure of angle y. That's 62. So to find the measure of angle x, you can guess, like, what number plus 62 gives you 90. But another way to find x, subtract 62 from both sides. If we subtract 62 from 62, we get 0. And x plus 0, well, here's the thing. Any number plus 0 is that number. Adding 0 doesn't change anything. So that is an addition that we can do with the variable. Now, x plus 1, we couldn't do anything. We really do need to know what x is. But adding 0 doesn't change anything. So we can add 0 to x just fine. But what we do to one side, we always have to do to the other. And so we get that x is equal to 28 degrees. Questions about that? So the next kind of angle we're going to look at, it's what's called a straight angle. This is an angle that's perfectly flat. And the measure of this angle, use this sort of arc. It's how we represent angles other than the 90 degree. On 90 degree, we use that little bracket. But for all the other angles, we use something like an arc. For this perfectly flat angle, the straight angle, measures 180 degrees. So this brings in another kind of angle called an obtuse angle. An obtuse angle measures between 90 degrees and 180 degrees. So it would be something like this. And so, sort of invisibly, this is the 90-degree angle. From here to here, this would be the 180-degree angle all the way over. So you have one side of this angle and another side over here between the 90-degree and then the 180. So this is your obtuse angle. So something else comes up with this. It's called supplementary. So two angles are supplementary if they sum to 180 degrees. So let me do an example. So angles X and Y are supplementary. That means they add up to 180 degrees. If angle X measures 120 degrees, find angle Y. So because they're supplementary, X plus Y is 180 degrees. Now X we know is 120. So again, to find Y, just subtract 120 from both sides. Now again, you could guess. You could say, well, what number plus 120 gives you 180? And you could figure it out that way. But we can do this method from algebra. So we're going to find out that angle Y is 60 degrees. So any questions about that? Now there's two shapes. There are two shapes that we want to kind of keep an eye on. First one, triangles. They always have three angles. Oh, hence triangles. Tri meaning three. The sum of these angles is always 180 degrees, at least on a flat surface. The other shape is a circle. And if you take a circle and you split it up into angles, the sum of all the angles inside of the circle, and this is a special, kind of drawing. I'm going to show you what this looks like. These angles are going to add up to 360. So the particular angles I'm talking about are angles with a vertex at the center of the circle. Now, by coincidence, I just did 4 angles, but there could have been 3, there could have been 20. But however I divide up this circle, the sum of these angles will be 360. All right, so let me do some examples with these. Let's take a look.
I'm sorry, it was A plus B plus C equals 120? Is that what you said?
A plus B plus C plus D. So it's going to be 360.
360, thank you.
No problem. So that's going to be the sum of those angles in the circle. I'll do an example of that right now. Let's see. In fact, let's do this. Find x. So for this type of problem, what we can do, we can imagine this being at the center of a circle. So that means this plus this plus this plus this, they have to add up to 360. So let's add them up. 2x plus x plus 2x plus 3x is 360 degrees. So again, we haven't talked about this yet. It will come up in the algebra chapter. But if you have 2 x's, and then you put in another x, that'll be 3x. Add in 2 more x's, so 3x and 2 more will be 5x. And to that 5x, if you add 3 more, you'll have a total of 8 x's. So you could just take 2 plus 1 plus 2 plus 3. That's going to give you 8. Now, there's another way we can do this. We can try to guess a number, some number times 8 is going to equal 360. There's an easier way of doing it. The trick that I'm using, we're going to study this in algebra. If I'm multiplying, I want to do the opposite. I want to divide. So if we're multiplying 8 to x, I want to divide by 8. It reverses what we've done. So if we're multiplying x by 8, we can divide by 8. So multiplying by 8 and then dividing by 8, well, that undoes itself. And so you're just left with x. But then what we do to one side, we have to do to the other. let's see here. It's going to be 45. So we find x. Now, we could go beyond this. We could be asked to find all the angles here. So we know that x is 45 degrees. So that means 2x, 2 times 45, I use my dot for multiplication, is 90 degrees. And then finally 3x, which is 3 times 45, is 135 degrees. So we can find x, we could get 2x, which is 90, and 3x, which is 135. Any questions about that? All right. Let's see. So another type of angle these are called vertical angles. Now, vertical angles really refer to angles across from each other. They might be vertically across, and this is kind of confusing. They might be horizontally across. But these are angles created by the intersection of two lines. So they're across from each other. And they're formed by the intersection of only two lines. So this is a very particular situation. So something like this. So what this means, I don't think they use this in the textbook, but this is a sort of a technique that's sometimes used in geometry to show that angles are equal. But angle x and angle y, in this particular shape where we have two lines intersecting each other, angle x will equal angle y. That means they're vertical. And then angle A will equal angle B. So the measure of angle x equals the measure of angle y. And then angle A and angle B, despite the fact they're horizontally across each other, we still call them vertical. So let me do an example of these. Let's see.
Sorry, it was angle, it was the less than A and less than B is greater than.
Oh, so it's angle A and angle B are vertical. And then the measure of angle A equals the measure of angle B.
Great.
So let me see. There's a couple examples I want to look at. And again, this is for a particular situation. Just because angles are across from each other doesn't mean they're going to be equal. So for example, just to kind of show this, if you have something like this, these angles are across from each other. Here, let me do this one, like, draw this one like this. These angles are across from each other, but they're not going to be equal. This is a line, sure enough, but this isn't a line. This has got this little bend in it. This situation of vertical angles is only true if you have two lines without any bends or breaks. So this is a line, but with this bend, the rule doesn't work anymore. It has to be the kind of situation where you have a line and a line with no bends or breaks. So in this case, these two would be equal and these two would be equal because there are no bends. When there's a bend like this rule doesn't work. All right. So let's say we've got this. So we have two lines. Again, no bends and no breaks. And let's say we have an angle 131 degrees and an unknown angle x. So what can we do? Well, maybe we can figure this out. Because these are two lines without any bends or breaks, the rule of vertical angles will work. That means this angle and this angle are equal. And this angle and this angle are also equal. Now, there's a couple ways you can do this. I'm going to show you the first way, where we don't really have to worry about vertical angles at all. We can just ignore it. You see this line here? We can redraw this as if it's a straight angle. And that this part of the line is right here. Here's x. Here's the 131. Now, because this is a straight angle, the total degrees from this side to this side is 180. In other words, these two angles are supplementary. So that means they add up to 180 degrees. So that being the case, again, we could subtract 131 from both sides. Let's see, we do that. should be 49 degrees. And so that's going to be our answer. Now there's another way you could do this too. And this is using the rule of vertical angles. And I think it's a little more complicated, but it still works. What we could do is we can imagine a circle centered here. So we have this angle, this angle, this angle, and this angle. Now, if you add up all these angles, they're going to add up to 360 degrees. And because this is vertical to that, this is 131 degrees also. And because this is vertical to this, that's also going to be x. So what we can do, we can add up these four angles. They're going to add up to 360 degrees. So that's x plus 131 plus x plus 131 is 360 degrees. Now again, this is something that comes from algebra. We're going to add like terms. So if you have an x and then another x, we have two x's. Then 131 plus 131 is 262. Now, when you get an equation like this, what you want to do is we're going to subtract this first, which is the opposite of addition. We're going to do the opposite. And then we'll do the opposite of multiplication, which is division. We'll cover PEMDAS later, the order of operations, where it says you multiply first and then you add. When you're solving for x, you go through the order of operations backwards, and then you do the opposite of what the operation happens to be. So instead of dealing with this first and then this, we're going to deal with this, do the opposite of it, and then deal with this, do the opposite of that. So the opposite of adding, subtracting. And so this will be 98. And then the opposite of multiplying is division. So we'll get x, again, is 49 degrees. So either method will work. You can do the 180 where you use the supplementary angles, or you can treat this as a circle. We have the vertical angles, and the sum of these angles inside this circle, it's got to be 360 degrees. Questions about that? All right. Well, let's see. So that's a particular situation, though, when you have lines crossing without any bends or breaks. Now, there's another kind of particular situation we're going to look at, and it has to deal with parallel lines. Probably the easiest way to imagine parallel lines, well, there's a couple ways. People will sometimes say that they're lines that never cross, or they're lines that keep the same distance between them. So you can think of it either way. So another way to think of them, think of sort of like train tracks in a straightaway. So this is our first line and this is our second line, barring some artistic license. Let's see if I can do that a little better. Guess I'll forever be not getting parallel lines perfectly parallel. I hope you get the idea. You can think of them like they're train tracks. They're just going to keep going and going and going, and they're never going to cross each other. And because they're lines, they're never going to bend. They're just going to keep going and going and going, keep going, going and going. Now, there's something called a transversal. It's a line crossing the parallel lines. It's a line crossing the parallel lines. So it's going to do something like this. This is a transversal. It cuts across these two parallel lines. Now, what's going to happen is we're going to look at, the angles surrounding the transversal and the parallel lines. So first off, what we're going to do, let's take a look at the angles on the inside between the parallel lines. So let's call this one, let's say, M and capital M. So these are angles that are between or on the inside of the parallel lines. And they're alternate sides of the transversal. So we're on the interior of the parallel lines, but on alternate sides of the transversal. And it turns out these angles have the same measure, and they're called alternate interior angles. Also, this angle and this angle. Oh, sorry, I got outside. This angle, again, on the inside of the parallel lines. Again, alternate on opposite sides of the transversal, and they're on the interior of these parallel lines. So they're also alternate interior. And so what we're going to find is this. The measure of angle M plus the measure of angle capital M, those two angle measures are going to be equal. Likewise, the measure of angle little m equals the measure angle capital. So alternate interior angles have this property. The alternates on the inside are the same, and then these other alternates on the inside, those two are the same. And there's another little property here we can kind of point out. The measure of angle little m plus the measure of angle little n, this is a straight angle. So this angle and this angle add up to 180 degrees. The same thing down here. This is a straight angle. So these two are supplementary. They also add up to 180 degrees. So any questions about that? Is it okay if I erase this here?
Yes.
All right. So those are alternate interior. Let's take a look at alternate exterior. Now again, we have two parallel lines. If these lines are not parallel, this doesn't work. And usually you don't ever want to assume that lines are parallel. They need to tell you that. They could just be slightly off, like 1/100th of a degree from being perfectly parallel. So usually we want to see some statement that says L1 is parallel to L2. And they usually say this using a symbol. The way they express this will be L1 and then two parallel lines, L2. That means L1 and L2 are parallel. So what we're going to be looking at here are going to be angles on the outsides of the parallel lines. So let's take a look at this. We have this angle, call this little a. We have this angle, call it capital A. Then we have this angle, call it little b. We have this angle, call it capital B. Now, we're on the exterior of the parallel lines. We're on the outside. But once again, we're also dealing with alternates. Little b is on this side of the transversal. And by the way, this is usually labeled L3 or sometimes T. They'll label it T for transversal. This little b is on this side of the transversal. Capital B is on the opposite or alternate side. Same thing with little a. Little a is on this side of the transversal to its left. Capital A is to its right. Again, alternate sides. So what's going to happen is something similar to interior alternate, alternate interior. Alternate exterior. And so what this says, the measure of little a equals the measure of big A. The measure of little b is the measure of big B. And just like alternate interior, when we're dealing with these alternate and exterior angles, little a plus little b is 180 degrees. And then same here, the measure of capital B and the measure of capital A, if you add those, you'll also get 180 degrees. So any questions about that? Now I'm just going to point something out, and I think they do mention this in the text. And I'll go through this in a bit. I'll put these back up here. But we're going to talk about the vertical angles, because if you look at this right here, this is that crossing of the lines. So is it okay if I erase this here?
Yes.
Okay. I call this C. Here's capital C. Here's D. Ooh, capital D. There's lowercase d. So just to review, if we think about alternate exterior, this A is the same measure of this A. This B is the same measure of this B. Now let's go back to alternate interior. On the inside of the parallel lines, this D equals this D, the alternate angle. And again, inside the parallel lines, this C equals this alternate angle C over here, capital C, little curly Q on top of it. Now, we want to talk about vertical angles. And again, at these intersections, this is the intersection that gives us vertical angles. So, that means the angles across from each other, because these are lines without any bends or any breaks, this angle and this angle are also equal. Likewise, these two angles are across from each other, so the measure of angle B equals the measure of angle C. Again, this is a lowercase c. So lowercase a, lowercase b, lowercase b, lowercase c. Now then we go to this cross. And again, no bends, no breaks. So this angle equals that angle. And then same here. This angle's across from this one. So when we have the two parallel lines and the transverse, we create some vertical angles. Questions about that?
That's
So,
good.
oh, I'm sorry.
Go ahead. I was just telling you I didn't have any questions.
Oh, awesome. Well, there's one more thing I'll bring up, and this one probably isn't as important, but you can think of this again as like a circle with a center, and then a circle with a center. So that means the sum of the angles in that circle is 360 degrees. So when we're dealing with transversals, there's a lot going on. And there's other things like, because this is a line or a straight angle, we saw this, A plus B is 180 degrees. But this also, we have a straight angle, so A plus C will equal 180 degrees. And we saw that say D plus C is 180, but also C plus A is 180. So there's a lot that's going on with these transversals. And let's do some examples. Let's take a look here. We'll dig into this. Oh, and there's one more verticals I want to do. I want to do one more verticals. And is it okay if I erase this?
Yes.
Awesome. So let me do one more example of verticals. So let's say we're asked to find x. And they're going to tell us that these are lines. That means no bends, no breaks. And that means when we have this particular kind of situation where they cross, these two angles are going to be equal. So that means this degree measure equals this degree measure. Now again, this is from the algebra chapter, so we're kind of getting ahead of ourselves. But we only want x on one side. So we could cancel this term if we have a positive 4x, subtract 4x. 4 minus 4 is going to be 0. So this will become 0. 36 plus 0 is, well, it's still 36. But what we do to one side, we've got to do to the other. So we're multiplying to get x by itself. We do the opposite of multiplying. We divide. And so we find that x is 12 degrees. So that gives us x. And if you wanted to find the actual measures of these angles, you could put in x here. And that's going to give you, and of course, the angle measure here will be the same here. But if you put 12 in here, you'll get 84. Put 12 in here, you'll get 48. 48 plus 36 also gives you 84. Because again, these two angles need to be the same. All right, so that was the one with vertical angles. Let's take a look at transversals. Let's see. All right. All right. So let's say squeeze that in there. So this is 47 degrees. So L1 and L2 are parallel. And then we have a line or a transversal T. So that being the case, we want to find A and B. Well, first off, let's take a look at A. A is between the parallel lines, so that means it's interior. Then it's on the opposite side of the transversal, or the alternate side, to this 47. So it's alternate interior to 47. So that means because it's alternate interior to 47 degrees, the measure of angle A is 47 degrees. And so there we go. Now to find B, we're going to make the observation that again, in this transversal and parallel line system, there are straight angles everywhere. Straight angle, these add up to 180. These add up to 180. These add up to 180. These would add up to 180. These add up to 180. These add up to 180. And these two add up to 180. So we can think of this is the transversal as it keeps going, but we can just look at this part of our transversal parallel line system. So these are supplementary angles. So we could subtract 47 from both sides. We'll get B is 133 degrees. And that's going to be our answer. That's A and that's B. So another version of this, any questions about that? All right. So let me show you another version of this. Let's see. So we want to solve for x. So what we can do is we can try to fill in missing information. Now, some of the fill-in we do is not going to be very helpful, but it's a little tighter. Let's see what happens. So first off, we know these two angles are vertical. So if this is 2x, that's 2x. And same here. This is x plus 39. This one's x plus 39. Squeeze that in there. Again, because they're vertical angles. Now, that doesn't seem to get us anywhere. There's no rule for adding these two angles. So at least you don't have enough information. So what we could do is let's use our opposite interior, or alternate interior. So 2x is here, the alternate interior is this. And now we're somewhere. Because now, these two are part of a supplementary set of angles. So that means x plus 39 degrees plus 2x equals 180 degrees. We can think of it like this. Transversal keeps going. We're doing something like that. So let's solve for x. You have an x, two more x's. You have 3x. 39 equals 180. So any questions so far? All right. Again, we're going to deal with this first, deal with this second. So subtract 39 from both sides. It's going to be 141. Divide both sides by 3. That's 141 divided by 3. 47. So that's going to be our answer. Questions about that one? I kind of feel like I did that one a little fast.
No, I got it. I was paying attention.
So the trick there was I just used vertical angles, and that got me so far. That did help. And then I started looking at alternate interior. Maybe I needed to look at alternate exterior. But eventually, we're able to get a situation where we have the angles next to each other. and they were part of a straight angle, or they were a pair of supplementary angles that completed a straight angle. And then you just add those up to get 180 degrees. All right. So there's one last problem I want to go over today. And it's this. So we're given this triangle, and what they should do, and they don't do this, they should tell you that these are lines, that there's no possibility of a bend or a slight curve that you can't quite see with the eye that would throw off the fact that this angle, whatever this is, plus this angle and this unlabeled angle, those add up to 180 degrees. So first off with this, you can do this in different versions. We're told A is 35 and B is 55. So this is what we've got. Now, what we can do, I'm going to be using this to help out. It might not be clear why, but I'm kind of a plan in my head. Finding y is not going to be too bad because this is a line. This is going to be a straight angle. So 35 plus y is going to equal 180 degrees. So we have this situation. And then this keeps going. So if we zoom in on this little part, this is what we've got. So solving for y, and there we go. There's y. Now, x is going to be a little tricky. So let's take a look how we can find x. We know this is 35. We know that's 55. Now, this is a straight angle. So that means this angle plus x equals 180 degrees. Now, how do we find this angle? Well, we know this angle plus this angle plus that, which we don't know, is 180 degrees. but we can find this one. This is another straight angle. So that means this plus this, let's give it a name, let's call it n. This plus this is 180 degrees. So just like we found y, we can find n. So let's say we found n. Then n, which will now be a known number, plus this known number, plus this unknown angle has to be 180. Well, we're going to find out what this is. This will become a number. So number plus an unknown is 180. So if we have an equation with just one unknown, we can solve for that unknown, just like we did here. So we can find this. And once we find this, we make it into a known number. This plus that, because this is a straight angle, that's going to be 180. Let's try it out. So I'm going to call this m. Now, if this isn't clear, you can experiment. You can say, well, what if we made this 55 because they're vertical angles, and then we can still solve for this angle. And you can find all the angles, and eventually you will see, hopefully, that, well, wait a minute, well, this plus this is 180, and, well, we're all set. Or you might actually find this one. This plus this is 180, and then whatever this is, it's equal to x. You could do it that way, too. So let's go about it like this. So let's say we have 55 plus n. This is a straight angle. It's got to be 180. So we've got this little piece. So again, we're going to subtract 55 from both sides. So we're going to get this. I'm going to circle it because it's not one that we're looking for, at least par as an answer. So I can redraw my triangle down here. And so now we've got this situation. So we've got this. So we found n, it's 125 degrees. So now we can find m using the property of a triangle that says if you add up all the angles, they come out to 180. So basically, we've got a triangle. Keep going. But this is m, 125, 35. So m plus 125 plus 35 equals 180 degrees. Adding these two together, (125 plus 35 is 160 degrees. Now subtract this from both sides. We get m is 20 degrees. And again, that's just something we're looking for. I'm just going to circle it instead of box it. So now we have this. update our triangle. So this is our situation. So the last thing to do, we've got supplementary angles that add up to 180 degrees. So this means x plus 20 degrees equal 180 degrees. Subtract 20 from both sides. X at 160 degrees. So finally we get x. Questions about that? So that's it for today. This went a little long. This is a long section, but those are the major problems I wanted to cover. So unless you have any questions, that's going to be it.
Thank you.